In our last class, we came to know the structure determination of glucose. That means how we have established the structure of glucose. Now, in our today's class, we'll see the open and close chain structure of glucose. That means glucose can be written in different forms. It can be written either in open form, open chain, or it can be written in cyclic form as well. Okay, let us see. So the structure that you are seeing over here is called an open chain structure. This is the open chain structure. Now, uh, aldehyde, one aldehyde group, and we have got four secondary alcohol and one primary alcohol. So the structure of glucose is written in this way. Okay, so over here you have to give the number to the carbon atom, so it will be easy for you to understand the structure. So starting from aldehyde, we have given the carbon atom number 1 2 3 4 5 and 6 carbon atom. Okay, now in this, what will happen, from carbon number 5 OH and to carbon number 1, what will happen, there will be a transfer of hydrogen. This is a carbon oxygen polar bond. So what will happen, the bond will break towards the oxygen atom, so it will be negative. Okay, so in that, this carbon becomes positive. So in order to neutralize the charge, this H will be removed as H plus and go there, and it will form OH. Okay, it will form OH, whereas this O minus will be linked with this carbon atom, so which is shown in this way. Okay, others are same, only there is a formation of bond with this between carbon number 5 and carbon number 1. Okay, now over here there is two possibility. This OH formation that is attached to OH, this can be either on the left hand side or it can be on the right hand side. Okay, it can be either on the left hand side or right hand side. Because of this OH group at carbon number 1, one OH on the left hand side and other OH on the right hand side, they are also known by a different name. So OH at carbon number 1, they are called alpha D glucose. Okay, and OH on the left, we call it as beta D glucose. Okay, this is another form of glucose, alpha D glucose and beta D glucose. Now now for this, after this, we are going to draw the cyclic structure for this. Okay, in the cyclic structure, we'll take the use of okay, the same structure. Now what we'll do is, the cyclic structure of glucose, okay, is similar with this pyrene structure. It is one heterocyclic compound where we have got the, in a closed ring we have got 5 carbon atoms and 1 oxygen. Okay, this is the pyrene, and there we have got double bond. So in a similar way, if you see the structure of this alpha D glucose, then it has formed a ring. Carbon number 5 and 1, they have attached and it has formed a ring. We can say one carbon number 1 2 3 4 5 and 1 oxygen. Similarly over here, so the structures look like similarly as pyrene. Okay, now for this, now we have drawn the alpha D glucose in cyclic form and beta D glucose in the cyclic form. Now we have to understand the structure, how we have drawn from this to this one. Okay, so what you have done is, you have just simply drawn a cyclic structure with the 5 carbon atom and 1 oxygen okay, and after that we have given the number to the carbon atom 1 2 3 4 5. Okay, now at carbon number 1, if you see this one, H this side and OH this side. So what we have done is, the groups which are on this side, it is written up, and the group on this side, it is written down. Okay, so at carbon number 1, if you see, H is up, so here H is up and OH is down. At carbon number 2, once again H is up, OH is down. At carbon number 3, OH is up and H is down. At here, H up, OH down. And in this case, we have got CS2OH. This larger group is written above, CS2OH, and below H. Similarly, this is alpha D glucose. This is the cyclic structure of alpha D glucose. Now in case of beta D glucose. Once again we'll draw the 6 membered ring with oxygen at 1, and we'll give the carbon number 1 2 3 4 5. After that again we'll see this side of the group is written up and this side is written below. So at carbon number 1 OH up, so OH up, H down. At carbon number 2 H up, OH down, OH up, H down. Okay, and at carbon number 4 H up, OH down. Now in the last case, as I said, CS2OH is written up and H down. So this we call alpha D glucopyranose and beta D glucopyranose. Why pyranose? Because it has derived from pyrene. Okay, now this alpha D and beta D glucose, they are also called as anomers. Okay, there is a term called anomers. That means they differ only in the structure at carbon number 1. That means the position of OH. In one alpha D, OH is on the right, and at carbon number 1 in beta, it is on the left hand side.